So this question comes from the house of fluid mechanics. It's based on the initial part of the fluid mechanics about the equations that we write of pressures. Basically, in this question, we have to apply that on pressure equation. So in this question, we are given a cylindrical tube with its base, as shown in the figure, is filled with water. It is moving down with a constant acceleration a along the fixed inclined plane and angle theta. So this is theta. This, then A is parallel to this inclined plane. There is a term beta P-1 minus P-2 over rho GD. It can be termed as a normalized pressure difference, where rho is the density of water, d is the inner diameter of the tube, and g is the acceleration due to gravity. Then, which of the following statement is correct? So first of all, let us work from the frame of reference of the inclined plane, because then only we could apply the concepts of fluid statics, which is much easier than if we do this by a inertial frame. So with respect to the inclined plane, the fluid is simply at rest, but it has two accelerations, g and a. A acceleration due to the pseudo force. This angle would be 45 degree. So first of all, can we find a general pressure difference between points 1 and 2? Yeah, we could do so, but we'll not move along the inclined plane. Rather, we'll create an intermediate point here. Say 3, and because these two are perpendicular directions, so we can easily write the pressure difference between 1 and 3 and 2 and 3. So net gravity or gravitational force acceleration along the vertical direction would be g minus a over root 2, and in the horizontal direction it would be simply a by root 2. On moving from 3 to point 1, we would get, we are moving from 3 to point 1, so p3 plus move a distance d, because this is 45 degree, this is diameter, so this will be also d, p plus rho g effective d equals to p1. This is the pressure equation along x direction, and pressure equation along the y direction would be, this is x, this is y. In this direction the gravity is increased, the effective gravity is directed, so we are at 3, so p3 plus rho ge dash into d equals to p2, or p3 plus g, sorry, would be rho, and what will be the g effective? G minus a over root 2, equals to P3. And for this you would get P3 plus rho. What will be the G effective in y direction? So simply A over root 2 to D into D equals to P2. Then we could find P1 minus P2 equals to D rho G minus root 2A. And if you can find beta from here, we would get rho D over G minus root 2A, or with a more beautiful, would get 1 minus root 2A over G. Now we'll check with the options. For option A, if A equals G by root 2, then what will beta? It will be simply 0. So this option is correct. And for the second option, this is not correct. For the third option, if A equals to G over 2, then we'll get beta as rho D 1 minus 1 by root 2. So there would be rho D, 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 because B is dimensionless. So it would be the same. So this option is also correct. So this is not correct. So the correct option for this question would be A and C. And I think this is the easiest method to solve this problem. Otherwise, we could have proceeded in that way. Suppose for first, if beta equals to 0, then it implies that P1 equals to P2. It means that 1 and 2 are at the same pressure level. So this line would be parallel to the would be normal to the effective gravity. So if effective gravity in the first case will act in this direction. If this is A, this is G, then we can find this angle. Of course, this will be alpha. No, this will be 45 degree. So if this is 45 degree, this is A, this must be A. So and here we put A equals to G value. But for the second case, it would be very difficult to solve. Not kind of very difficult, but suppose this is the liquid surface at the top.
Recording.
This will be the theta, which is making which the liquid is making with the horizontal, and this is G. A would be still acting on 45 degrees. So the resultant would be normal to this surface, and this is not a right angle triangle, so it would be time consuming to use some triangle properties to find out the angle and finally the value of the effective acceleration. Here we could build some equations. This will be theta, and this would be 45 degree. So this would be 135 minus theta. Now from here you can proceed using the sine rule or any general rule of a triangle.